Hey, hello guys. Hope you guys are doing good. Let's solve today's daily challenge. Today was second day of this month, 2nd July, I think, if I was not wrong. Okay, the today's question was 3286 find a safe walk through the gate. Seems a good one. This question I haven't solved it before. Okay, you are given a matrix and health. You start from the top left, upper left. Okay, and then and would like to get to the, okay, we need to start from the top left and then the bottom right, so we can just move in all four directions from one cell to adjacent cell as long as our health remains positive. Okay, if the grid is 1, if the current cell is 1, that is considered unsafe and reduce. Okay, and then it reduce the health by 1. Okay, return true if we can able to reach the final cell with the health value of 1 or above. Okay, see, okay, what is the matrix size is 50 or 50. hmm Seems interesting. Okay, so the constraints are like m and both m and n are less than or equal to 50. So in a worst case, it in m times of n we would get we would be we are getting around 50 times of 50, which is 25 times of, like, yeah. So we can say something like this is big O of 2.5 times of 10 power 2. Is it, no, 2.5 times of 10 power 3, yep. uh, so if we ignore this constant, so we have only 10 power 3, which seems good, like more straightforward one. And then the health was, okay, what are the values of the matrix would be? Either 0 or 1s, or like, okay, all the grids, all the cells could be either 0 or 1. Okay, this is important thing to notice. And then, okay, this is fine, the upper bound and lower bound. And then the health could be m plus n time. Seems this is also fine. This is also like not very much into this question, right? So actually our question was like, so we are just starting from this top left and then we need to go to the bottom right. So and then for if it is a 1, we need to give our health by 1, and then if it is not 0, we need to give our health by 1, and then we can proceed further. So the question is like, whether we can able to reach from the top left to bottom 0, like, okay. Actually I was thinking like, the base, like the simple BFS will work. Yeah, the simple BFS will work. Anyway, it is 50 times of 50, right? So I'm just planning to use a simple BFF with the heap of the maximum health, so that, yeah, 50 times of 50, and then the heap operations, 10 power 3. So at max, if if I was just telling like, if k equal to m times of n, so the overall, okay, I'll just type it over here. So TC. So we can just solve this question by basic BFS. So the time complexity of the basic BFS will be like, the 4 times of m times of n, 4 times of m times of n. So which means that for each cell we are choosing 4 different directions, right? So if this is the basic, this is the BFS one. So if we are just using a heap, it will just give like, if k is the m times of n, if k if k was m if k was m times of n, so we can just, it will just land in k times of, we go of k times of log k. Okay, for this question, that is a good one to go. We can just try doing in both the approaches, like, so the states could be in the index I, and then index j, and then our current health. So we can move in all directions, right? So this is my way of doing it, like create the all directions in previous, like we can just create, like we can just make this as final because we're not going to change it, and then make this as static as well because this is common for like all the objects of this class. So yep, so first we can just go to top and then bottom. Okay, and then left, so left, and then right. Good enough. So yeah, so name this as cube. Instead of naming this cube, can name this path. Mm, yeah, pass both the values, and then here we are just giving the high priority for the health. Who has the higher number of health, right? Um, yeah, so it has something do like something like visited kind of stuffs. Yep. So I was thinking like, wait, I have a question like how we can just memorize like what is the current health we are in. For each cell we have all three options, right? So for each cell we can come up, we can just land in like the with different types of health, right? So how are you just going to just memorize the current path? I think for this question, like this is simple boolean return. I think the simple DFS will work. The DFS will work. I think we also do it in BFS as well. Like instead of doing it in a recursive way, DFS like basic BFS will also work. How we can do it? Interesting. So anyway, we need to know. No, I'm just quitting this approach and then planning to do in a BF like recursive way. So that if the recursive way could be if the m times of n and then 50 times of 50, right? So the health could be m times of the health could be m plus n. So yeah, so the time complexity for the recursive approach would be 50 times of 50, and then what else we are doing it, so like for each cell, this is for each cell, and then we are doing going in the four directions, and then that could be the constant, and then what else, and then the health, right? M plus n, so at max 100. So we go off, and then if we just do some math, it will just give you something like 25 times of 10 power 4, and then if we still do if we still like do something like 2.5 times of 10 power 5, yeah, we can just do it, and then the space could also be the same, like both time and space also be the same. Yeah, let it be. Okay, we need only boolean approach, right? Yeah, find a safe walk and then pass the current. Okay, current index, and then pass the current health as well, and then grid. Oh, here they're having list of list. Usually I don't like preferring having the collections of collection, because like if it is a grid, that's a straightforward, right? We can just directly get, hey, grid of ij, but this is very little frustrating. Okay, we can do. So yeah, our approach, the base case was like if my I was, we can just still pass the bonds like the cells, like okay, if m minus 1 and then j was n minus 1, hey, I reached, so I can able to reach, so return true. So the one more check is like before this, if my health no, we can just do something like okay, we don't need to check the health over here because can still able to go, right? If it is, if health is 0, like let's say example, if you are currently in this position and then this is the path, like the gray one, right? If you are in this position and then in this position, if our health becomes 1, okay, if our health becomes 0, we can't proceed, right? They are asking it if the value of health is 1 or more, so we can simply say, hey, if my health was less than 1, I'm going to return false. I think this could be the first condition. So and then after that, if you are, even if the health was, if the health is greater than 1, and then if we are able to reach the last portion, that is what we actually needed, right? So yeah, so just go for each directions. So yep, take the current index and then okay, just compute the next the cell which you are going to land, and then this could be the J, and then yep, Y. So how we are going to memorize the current cell? Mm, we can say something like and we can just take the temporary of it, and then dot get of I dot get of J, and then make make this current cell, make a current cell as -1 or something. uh, get of I dot set this J as -1. Yep. So here we can play we can just play our stuffs. Okay, if it is not the, if the next landing cell is inside the matrix, first do it for that, and then what else? Okay, yeah, that's what needed. So and then check like, yep, so you put listen 0, and then if it is good to save for a walk, like X, and then the next cell, and then pass the M and N as well, and then health, right? This is what like, so okay, reduce, you can just say reduce something like, okay, grid dot get off I dot get off J. Oh no, we can't do it, like okay, yeah, that's a thing, right? We can just utilize this value. No, we need to use this. If X and Y, if my current landing cell was 1, I need to reduce, or I don't need to do anything. So reduce the current health minus reduce, and then yep, and then pass the grid as well. So if this guy returns 2, then return 2 for all his ancestors. Simply return false. Yeah, we are good enough. So dot size dot get off 0 dot size. Yep, you can just directly return find safe walk of a top left, and then pass our current health. Okay, and then grid as well. We are good enough. Try submitting it. Okay, nice. Stack overflow. Interesting. Okay, because we are not setting it, and then we forgot to add one more check as well. And grid dot, if it is not -1, get off I dot get off J, which is not -1, I mean to do, and then so this check is for like not for visiting the same cell again and again. Like let's say example, if we are just from 0 to 1, 0 to this cell, and then like while passing this cell, we are passing all in all 4 directions, right? So if we process the same, the upper cell again, we are just keep on just going in the same loop again and again. So we don't want to do that. So this way, and then give the value back. So what else we can just do is like, okay, 10, yeah, this will work. Nice. Okay. Okay. What did I missed? Where I made a mistake? How it come? There is a value of cell was there. Okay, got it. So we need to handle one more case. We need to handle the parent case. Okay, I've just come. So from this test case, okay, I've just come up on the part. Before that, I need to check why this this case is failing. So if the direction was correct, yeah, direction was good, and then this was the edge case, and then okay, oh this guy was the current cell, and then current cell was one, reduce him, will don't do anything. Yeah, we are good enough. How come? Okay, yeah. So the case which I was trying to say is that the parent cell, which means that okay, okay, what else? This is five. Okay, the parent cell is like, what if the starting cell was zero? Like here we are not caring about the starting cell, like the reducing health. Here we are only cared about the next landings. We are reducing the health only to the next landing cell, right? So we need to do the same for the starting cell as well. So if my top left was 1, then reduce something, right? Then reduce 1 to him as well. That was good. I was thinking why the second test case has failed. It was not supposed to do. Okay, this was false. Okay, my case is giving as true, which means he's telling, hey, I can able to land. How come? 1 or above. Okay, we can do go in all four direction to another suggestion if your health remains positive. Okay, if it's positive, we can go. And then if it is negative, then we are simply dropping off, right? Yeah, with grid of 1, consider to be unsafe and reduce the health by 1. Final cell value 1 or more. Okay, that's good. Why my case is giving? So, is there any valid path? 1, 2, 3. No. Okay. So, I need to track what is my current health being there when system dot out dot this. What is my current health value if I was landing on the last cell? Which is 12. What? How come it's 12? Seems like something is happening in the -1 part. 12? That doesn't even make sense to me. Initially I was 3, and then after reaching -1. Okay, okay. I made a mistake. Like I need to plus it over here, right? Oh, silly mistake. Here, because here I was doing -1, and then I was just adding it again with the same negative sign. Yeah, definitely it will just reach time limit exceeded. I don't want to test that. I will directly memorize the stuff, memorize the path. It's a 3DTP. Let's do it. New integer of yam and yan, and then that max our current health. We are good enough, and then just do the memorize part. Like if our current, if my, if I have already seen this state, then I don't want to process it. I know it is a boolean, right? So it's not integer. So go with the boolean stuff. Yup, here we go. If I already seen this path, please return, please return it from the cache. Yep. We can add submitting it, runtime error. Nice thing. Out of bonds. What? Index 6 of out of bonds. Bad. What? How? Health plus 1. Five plus 1. This seems to be good. Seems like somewhere our health is getting increased. Interesting. I want to check. How this health guy is becoming increased because we are not doing it anywhere, right? Seems in the first. Oh, here, like here we missed. Here we missed to like here we are just doing reducing the size, but again we are just doing the minus over here. That's the issue. The the simple math. Okay, that's fine. We are good enough. Hope you guys understood this. We are good enough. That's fine. Hope you guys understood. See you tomorrow. Stay consistent. Bye.